Okay, I think we can be now. Let's go ahead and get things started here. So we're going to go through a little bit of UI Toolkit, which has been around for more than a few years now. But recently, with Unity 6, they have made some updates that have made UI Toolkit a lot more enticing to use during runtime gameplay. For the first few years, UI Toolkit was basically um, editor tooling. So you would make a bunch of like custom editors and tools and stuff that you would use in the editor with UI Toolkit. But now you can, they have introduced a data binding system. So this will allow you to tie values in your game directly to the visual elements. So for like this health bar, for example, can be bound to the health of your player. But first, I guess we need to step back and take a look at what UI Toolkit actually is. And this is a more web dev focused. Um, I guess they took inspiration from web development in order to create more flexible and scalable UI system. If you've used Unity UI before, they call it UGUI, and it is basically you have a canvas as a game object, and then on that canvas you put various 2D elements on your actual game objects. And this is really quick and dirty, but also it ties up your data into the actual UI visuals as well in a way that is kind of um, not very conducive to more data oriented design principles. All right, so what I have here in front of us is the UI Builder window. And this is kind of just a separate editor window specifically for UI stuff. You don't have to use the UI Builder. Some people really hate this and they find it clunky and whatnot. But what this is it's a way to manipulate and create your different files for your UI. So it's split up into specific parts. If you've ever done any web development, this will be very familiar to you. So we have style sheets and we have the actual XML for your hierarchy of visual objects. And we also have down here this preview. The UXML is very similar to HTML, and our USS, which is the Unity style sheets, it is basically a subset of CSS. I am not a web developer, so I may be getting some of these terminologies completely wrong and backwards. Just drop me a comment and tell me how wrong I am. So down here in our library, we have some standard visual elements that we can drag into our scene if we want to. Some of these are editor only. Like I said, this used to be for editor tooling only. So you'll have a bunch of these fields that are just used in the editor for like custom inspectors and whatnot. Everything else that does not have this editor only tag here are things that we can use um, in our game. So I guess what we can actually do here is run through a bit of some of the samples they have. I'll get to some of the other windows that we have here, but I want to go over the base UI toolkit first, and then we'll go into app UI and kind of their more. This was built on top of UI toolkit. That is supposed to be more, I guess, app focused. So for your Android and iOS platforms, this has hooks that will hook directly into like your dark mode themes and localizations and things like that. So here in the UI Toolkit samples, you can get to this from the window UI Toolkit samples. And this will bring up this window. And this is just examples of the different visual elements that we have access to here. And you'll see the XML here at the bottom, the style sheets for it here in the middle, and then the C# logic, which is where you actually can directly access your objects and query the document for your different elements, and then you can manipulate them in code directly. The styles here, this is for like dark mode and light mode for our various buttons and whatnot. All right, let's get this out of the way here. And I want to go through a little bit of this is the Quiz U sample. And this was released a couple of years back. I wouldn't say it's out of date, but it does not have a lot of the newer improvements and features that were recently added with Unity 6. But it is a really good educational program for going through the UI toolkit. So it actually should be wider screen, but that's fine. Here we have our play settings, and all of this was built in. We got some music here. All of this was built with UI Toolkit. Here's some of the demos. And I guess we can just go from top to bottom here. So again, here is the UXML. This is how your hierarchy is kind of set up here. You have various attributes that you can set for the position according to how it is laid out in the XML. The draw order is from top to bottom. So the things higher in the tree are rendered kind of behind everything else. So it is kind of a layered approach here. So things on the top are rendered first, and then all of the children and lower items are rendered on top of that. This also uses Flexbox for positioning and expanding and shrinking the various elements. So everything will scale according to how your screen layout is. So if you're on a widescreen or portrait or landscape or whatever, then it will adjust accordingly. Here, UI Toolkit has its own event system. which we'll look at in just a bit, and how it will dispatch events and for your different items like your button clicks and sliders and event fields, and it will pass different arguments up and down the stack here. Okay, for Flexbox, you can have it wrap in various directions here, and this will just let you play around with your different wrap modes and where it's justified, either left, right, top, or bottom. We can take a look at some of this actual source here. So instead of a canvas and panels and whatnot in the scene, we just have this UI document component, which will have to be in the scene in order to be rendered. But this is the only game object you actually need. We can look a bit about the panel settings. So here it will grab the reference resolution, which is usually going to be the max of what you are actually designing for. So this will just be, 1080p. This is also where, I don't know if we can look at this now. This is where you can set up world space panels as well, which is new-ish. I think it's still experimental because you can't actually see it here. If you go into, let me do this in play mode. Yeah, if you go into debug mode in the inspector here, you can see the render mode, but you can change it from screen space overlay to world space. And with the panel settings as world space, this will make this screen here in a world space. So it'll have a position and scale and whatnot that you can use. We can look at one of those. Look at those in a little bit. But when you open up the source asset here, this will open up in the UI inspector. And here, this to be, all right, well, it's kind of hard to see them both, but here we can look at the different panels and sections of our UI elements here. Here in the style sheets, this is where we have our different style classes and also the pseudo classes here for our sliders. In the inspector, if you click on the hierarchy here, you can see the other attributes that we have here. These are the inline styles, so we can change these directly without having to go through our style sheets. We'll go over bindings last. That's kind of the newest thing here. So also here is where the Flexbox really comes into play here under Flex, which we can also set these in our XML directly if you wanted to. If you're more code driven, you can open this up in Visual Studio here. And here you could edit it directly if you wanted to. Some people like to be able to just type out their buttons and whatnot directly in the code, which is good if it's a smaller screen that you're working with. But for larger, more complicated scenes, I don't know. I like the UI builder. All right, let's see. So we have our different CSS files here, our elements. So the elements have names here, and the names have a pound hashtag in front of them. The class names have the periods in front of them. When you're referencing these in your scripts, they are referenced by strings. It's kind of unfortunate, but that's kind of just the way it is right now. So you do have to keep in mind when you're referencing these that you don't make any typos and whatnot for any of these. Okay. So the CSS styles, this is where you can have greater control over how your different elements will actually look. So here we have different buttons. These are just all buttons, but the way that they look are dictated by our CSS style. And you can switch these out at runtime as well. And also we have theme style sheets, TSS files that are just a collection of USS styles that can all be changed at the same time. So you can have like your light theme style or your light theme, dark theme. You can also swap out themes for like holiday events. So you can reskin your entire game around different holidays or seasons. So you can have a winter theme, a Halloween theme, Easter theme, or whatever. The attributes here that you see over here in the CSS style, these are all pretty standard. And you can look these up in the documentation if you just want to know what these actually do and what they mean. They're also in here in the UI builder. These are all the same attributes that you can change from the style sheet. You can even, if you change these inline and you want to break it out into its own style sheet class, you can do that. There is a hierarchy here for style sheet changes. So we have our theme at the top, and then we have our style sheets here that will overwrite the theme. Then we have inline here. Anything that we do inline will overwrite any style sheets that we have. And then finally, in the code in C#, we can also change any of these styles, and code will take precedent over all of this. So if you have a specific button or text box or whatever that you want to change, if you do it in code, that will override everything. So that is something to keep in mind if you accidentally or on purpose change one of these inline attributes here. If you then add a class or another style sheet or even a theme, it won't be affected by what you had in your inline. So you might find that you changed something here and it's overriding everything else that you were trying to change. Okay, so uQuery, which I believe is based off of jQuery. Don't quote me on that. But uQuery is how you can find your different elements in code. So here, if you want to find this specific slider and you want to know what value it is, you can use the query of here, Q visual element and the class name. So you do it by name. So those strings I was telling you about, super important here. And then here you can nest them as well. So you can find the outline slider and then get the dragger, which is the little handle here. You can grab that as well. And if you have multiple items of the same, then it will just find the first one and return it. So when you do a query, you can do it with either Q, that will return a single one, or if you type out the full query, you can get the list of all of them if you want. So you can do everything with all your buttons if you want to. And this here is an example of how you would use this in C#. All right, I'm not going to go through all of these. Do have pseudo classes. So the pseudo classes just give us various states of our different elements here. So if it is hovered, you can do different transitions to other states and other animations. So if you want to search for all of your toggles that are checked, you can do so. Or if you only want to do things when something is focused, you can do that as well. So these are kind of the different states of what your elements can be in. So that is kind of the bare basics of UI Toolkit and UI Builder. Let us talk a little bit about App UI and how it's built on top of UI Toolkit. So in our package manager, we can look at App UI, which I don't think it's actually in. We had to install this by name. And it's just com.unity.dt.app-ui. And this is on 2.0.0-3.17 at the time of this recording. All right, so I guess we can go look at some of the samples here. Okay, so I'm not going to go over through all of these, but some of these are what we want to look more closely at. So here we have a theme selector here. So this can tie into your device OS themes here. There are specific hooks that are into the actual operating system. You also can do left to right or right to left, depending on localization as well. This key that you see here with the at app UI selected items messages, this can be used with the localization package in order to localize this message to whatever languages that you have set up. These are just the different buttons with the different themes and settings that you can have here. I think they call them variants. So we have a bar that we can, if the screen is too small, it will automatically pop a menu out for you. That's actually pretty cool. You can do it vertical and horizontal. These are spacings for avatars. So if you are in a social media type application, this can show different avatars in different locations, grouped up, pictures without. I do like the groupings of avatars, kind of how Google Docs will show you the avatars of everybody viewing that document. And these badges here, these will look familiar for application icons to show usually unread items. A lot of these are for navigation purposes. So like the breadcrumb here, this will show you like the hierarchy of where you are, so you can go back to different screens. There's a neat navigation system that's set up that we'll look at in just a second here. It's a little bit. So here is the scroll wheel or this canvas. Middle mouse click will let you pan around. And then for this editor one, you can still grab with the middle mouse button, but the scroll wheel here is for zooming in and out. And it will zoom in on where the mouse position is. We have our checkboxes, our different buttons here, color swatches, fields. The dialogues are actually pretty neat here. So here we just have a different alert dialogues that will pop up, and you can cancel or confirm. And you can see here in our console that we can do things whenever we are either canceling or confirming. So the modal here will stay up until you hit the X. The alerts have the confirm button, and here is the full screen one if you want to make double sure that they see what you want them to see. We have the trays here, which is from the bottom, left or right. Dividers, drawers. I don't think the drawer, there it is. The drawer is similar to the tray, but the tray is full screen. Your drawer is in another panel. We have our drop downs, which I think are busted. Slow. There is a drag and drop elements here. Elevations are just the different types of shadows that you can have for your different buttons and other elements. Number fields, grid view. This is good for inventory type things. Mason view for offsets if you wanted a more visually interesting grid. Haptics, I believe this is just vibrations on the device, which can't actually do that in the editor. Different headers, icons. There is an entire icon window here in, don't know if we have any icons so we can search. Let's see, not show what I wanted it to show. Might be because I'm in play mode. Anyways, you can add new icons if you want to from that icon browser window. Okay, we got our labels, text. We do have pages here, which is pretty cool. Vertical and horizontal. Our preloader here, if you want a loading screen built in. Got different progress bars. The indeterminate is just if you don't know the actual progress, we'll just cycle through this. Quotes, radio buttons, slider, more sliders, split view. One of these I wanted to get to stack view. Stack view is really cool. This can show basically I guess the last of a list of items here. So all of these have different state animations. So there is a push animation. You've got a pop animation for going back down. Pop the last two if we want to. Drop everything but the last one. Basically, this can be... I wanted to use this for a deck of cards, but it only shows the top of the stack, basically. So even if we draw 5 or 6 cards, we only see the last one. There's not really a good way to see like 5 cards at a time. For that, you would need to use the page view, which is somewhere else. But I do like the different animations here. We'll look at that in... I've got this specific one in a different scene that we can look at. The swipe view is actually not bad either, which I think there is a wrap. This one might be what I end up using for cards. Error message. Vertical tabs for different tab-based UIs. Text. Toast. Toast is another one I wanted to check out. These are basically messages that can be popped up in different locations, like achievements and whatnot. I really like the slide animations that they have. And you have these that will stay up until you dismiss them. Okay. So here we have that same scene, but this is actually using the world space panel. This is doing it a little bit differently than the way that I showed you. This one is not using the world space render mode here. And that's because it needs to handle mouse clicks and stuff as well. So what this is using is a other mono behavior here. That is basically going to translate your mouse raycast into the world for you, basically. So here we can take a quick look at this here, and we can still scroll and click on things. So works, which is pretty cool. I want to use this for VR eventually. I don't know when I'll have time to do some experimenting, but I like the potential this actually gives us. Because the World Space UI is kind of the big stopping block in using UI Toolkit in XR and VR applications. Okay. The other thing I wanted to check out is the App UI Storybook. And this is something I was not familiar with before, I don't know, a week or so ago. This is apparently based off of Storybook.js, which is kind of a testing suite for testing out your different layouts and visual elements kind of separately from the actual application. So you don't have to always build out an application or web page or whatever. If you want to test out different themes, scales, localization, I believe is a big one for this. So if you wanted to test your layout in Japanese, you can do so without having to rebuild your whole project. So here we can look at the UI kit scene that we just had open. This is basically done in this storybook. And then here I can change our theme to whatever, see how things look. We can change the layout direction and the scale. We can scale it up if we're on a bigger device. And we can do all this in this separate storybook environment. Now, was it storybook? All right. So here in the storybook samples is you have these .stories files. Kit, I don't see. Select navbar. So here is our button navbar. The navigation bar will basically always be in the top. I think we can stories. So with the app bar, this is the app bar, which is basically a top menu that will always kind of be floating up at the top, depending on where you are. So if you can scroll all the way to the top, it will expand out. You have different menus here and here, a header, label, and a button. So if you look at how this story comes together, we have a class that inherits from storybook page, and then we give it a display name. We tell it what type of component this is going to be, and it is an app bar component, which I think is down here. App bar component, which inherits from storybook component. We tell it what UI element type it is, which is it's an app bar. And here during the setup of the storybook component, we just give it some base styles. So it's just going to be a stretch. So it stretches across the entire screen. And then in the app bar component constructor, we'll add some of our properties here. So this will add a string property of the title. We give it a button with the button.title. And then this will be a button in value. So when you click on it, it will change. And then here is the default story. So this are the story books. These are the stories that you can have within your storybook. The canvas is basically what you can change in the editor here. That is a typo. That should be with button element. Anyways, here is our default story here, which is in default this. You basically just give it an empty visual object, and then you can just set all of its styles in line here. We'll give it a new app bar, do the same thing with our app bar. Here is how you add different visual elements to your root here. So the root visual element will kind of be the top level visual element of the entire UI document. So anything that you want to add to that, you can just use root.add. So this will add the scroll view that we just made with its style. And our scroller is hidden, so we don't see the actual scroll bar. We'll add the scroll view and then the app bar to it. Here we are adding our different items. So we're adding 25 items. This is the style for it. And then we just added the item to our scroll view. And then here we just have an event. Whenever the scroll value changed, we will scroll up, basically. And then here, this is a geometry changed event. So this will get sent when the actual dimensions of the element change. So if you are flipping from portrait to landscape, that would change this geometry changed event will trigger. And then it just resizes accordingly. This will also control, you saw when you scroll down, this will change the padding for the view as well. So each of these visual elements here is going to be part of your stories here, the different ones. So you can test kind of A/B test which ones you like better, depending on the different sizes you have. So then we have width, button. Okay, so here, this is adding this CSS class to this button container, and this app UI elevation 8. This is a class that is, I think, in one of the default Unity CSS themes that are kind of in, let's see, here in the panels. So your panel setting has a theme sheet here. So you don't necessarily have to create a new style sheet for every UI document that you create. Let's see. Ways. These class lists are in the documentation as well. I think here is our compact story. All right. Yeah, so that's kind of the basics of how the story book works. I'm sure there are a lot of things that I have left out and some more nuances that can make this a lot more useful, but I think it's neat. All right, let's look at the navigation graph here. So, okay, then we'll get into Redux last. Okay, so the navigation graphs here, these are ways to control the flow of your app in various screens here. So we have destinations, which lead to actions, which will lead to other destinations. So here we have a splash screen that will go either to an authentication screen or to a home screen. And these destinations will all have these labels and the template. So the template is the actual like UI document that will get shown. So here, these are, I believe these are just grabbed like through reflection from our, I guess they're just all in the views here. You can choose to show the bottom nav bar or the app bar, the back button, the drawer, or the navigation rail. And those are just the various menu items that you can have. Our actions have animations, so you can have a enter animation and an exit animation, or a pop and exit and enter animation. These are the different easings that you have. So you can either scale and fade in, scale and fade out, or just fade in and fade out if you want. There is a kind of a tween library built into UI Toolkit as well. There's also a scheduler that you can use for timing things that I did not see documented much anywhere. So let's look at how this will actually work. So here, our UI document does not have a source asset. We're using the navigation graph asset. I think we can. It's up here. Yeah. So here is our UI document. The graph asset is what we were just looking at here. And there's our panel. Yeah. So basically what we are doing is we're just grabbing our empty UI document and then we are just adding this panel, this app UI panel that we are just created into it. And then from that panel, we add the navigation host, which will spin up our navigation graph. We're stretching the panel to the parent size, so it's going to be full screen. Then we add our nav host to it, and then we stretch the nav host out to full screen as well. These are all of our views here. We can look at, they made these really backwards here. So here near the bottom of the views, we have the visual controller. This is where it is going to, where you start from. And this will have all of your navigation buttons here at the top. And actually, I guess this one is at the bottom. Our app bar will be at the top here. And then the setup drawer, which I believe is on the right side. And this one is not actually using the navigation rail. So let's take a look at this really quickly. Here we can set at the top here to follow the navigation. So we can put this down. All right, so like I said, from the splash screen, we have our splash screen template, which I believe will actually go to our home screen since technically I think I've logged in before. Here, this will fade in our screen to our home screen, which is here in a sub graph. Double click on it. We get our home screen with its label, and we'll show the navigation bar, app bar, back button, show drawer, and we have our template here. We can also generate code from this graph. Since everything, all of our labels and whatnot are all strings, the generated class here will basically have const strings for all of our strings here, so we don't have to mess up and make typos and whatnot. So we have our actions, which are moving us from one screen to another. We have our destination screens, and then we have our different graphs and subgraphs. Pull up here for our different screens. This is our splash screen. Every screen has a exit, enter, exit, and maybe just those. This is our splash screen. We do have the hierarchy, which is the actual element for this screen, where this is the splash screen adding our preloader to it. The preloader was that Unity icon with the circle going around on it. Here is the scheduler. This is what I was talking about earlier on how you can schedule different like animation events, so you can make more complex actions this way. This is basically just going to execute this after 3 seconds. So it's going to sit on this splash screen for 3 seconds. Then it's going to set player prefs for logged in. Well, it's actually going to check the player prefs for the logged in variable. And then this should be 1 if we're logged in, or it will be 0 if it has not been set or is logged out. So this logged in will be false. If we have not logged in, then it will take us and will navigate to the actions here. So this will go on that top route here, splash to off, or we navigate to the other action, splash to home. The home screen, these are real simple screens here. It's just a text that has the text content class on it. Added it. Here's our button. The button just goes to the profile page. When it's clicked, it will navigate to profile. It will also pass in these 2 arguments, which don't do anything, but this shows that you can navigate with arguments. And actually, when we see the profile page again, here we go, our settings. So the navigation screen here, after we set everything up in the constructor here, we have an overrided on enter and on exit. And on enter, we are grabbing the arguments that got passed to us and just logging them out. And then we have an on exit here that's just debugging, exiting the profile. So anyways, let's take a look at this. Okay. So here's our drawer. In our home screen, we have our item screen, and we have our profile screen. Settings. See that we've exited the profile screen here. Our theme can be set. light or dark. We have our back button. Now we can go back into our home screen, or we can look at our items. Settings, back to dark. Here we have our various items here. If we click on one of these items, it will take us to item details. And then we have our back button, which is always shown here. Our back button and the app bar. Here we have our drawer, items, our app bar at the top here, our back button. Back button is actually not shown, and our navigation rail is not actually being shown here. So yeah, that is kind of how you can create kind of more web app type screens using app UI. So yeah, I've logged out. You can have different links here, which will take you to different screens. Actual login does not actually do anything. I guess technically it will set your logged in player prefs to, okay. Okay, last thing I wanted to check out is the Redux. Redux is kind of a extension, I guess, of the React.js framework. And what Redux allows you to do is manage your application state in such a way that it lets you drive your UI through state manipulation, basically. I've not gotten as far as I wanted to in kind of wrapping my head around this, but we can check this out here. So we can check out the Redux example. So what this does is we have basically a data store that we can add our states to, and then we have what they call reducers that are actions that get dispatched to our store to change that data. So in this example here, we have a state that is just a counter. Let's see, where is that? This is just a record, which, as it says here, it's new type. It's new in air quotes from C#9 that kind of allows you to create a struct that is read-only. It is immutable. So if you want to change this state, if you want to increment this counter, then we need to grab a copy of the current state, add our value to it, add 1 to the value, and then we need to make a new state and then overwrite it, basically. And this is very useful for when you have larger projects and you might have different functions that could be acting on your data store at the same time. So a lot of your web apps will have asynchronous calls out to the web. So you might have a database call that is doing something that is like retrieving data or something that will like add to your inventory, say. That takes time. So you might also be using an item like a potion or whatever, um, while that other database fetch is still going. So it could be that you have um, states that are being manipulated at the same time. You don't actually want that to happen because you end up with like race conditions and whatnot. And, you know, what is your source of truth for what the actual state of your inventory is? And that's where Redux comes along. So we have our state here, which is the ultimate source of truth for your application. So in this case, this is our counter. So we have reducers that will manipulate our state and then save a new state. And then those different manipulations of the states can be saved. So you have a clear timeline of exactly the exact state of your store at any given time. So we can undo and redo different reducers at different times. We can show that a bit here. I mean, not in this one. Let's see. Well, let's finish up the Redux sample before I go into more. So we have these different strings. These are the reducers. So we have our counter slice. So the slice of our store is basically the name of it. And then the name slash verb here, this will be our action. So this is going to reset our counter. This is going to increment our counter, decrement our counter, and this is an increment by, and this will be an action that takes a parameter. So here we have our action creator. This will take a string. There's lots of strings going on in all of this. This is why we have our constant string, so we don't end up typoing something here. And we have our action creator with a parameter here, which is very similar to regular Unity actions. Okay, so here we are actually creating our data store. So we create a slice here. We give it our slice name. We give it an initial state, which for our counter is going to be 0. Back here, counter state. We are just setting it here with a value, and then we're setting it that value. So this can be whatever. And then after we set the initial state, we have a reducer, switch builder for our action reducers. So here we have builder, build case. It's basically a switch statement that will get passed in these different actions. And then depending on which actions get called is which reducers actually get called. Look at them real quick. So this is just static class with our reducers to make things a little bit easier to call. So here we will call reducers.increment, and this will return a state. And then you just call with, because it is a record. So you'll just call this state with this value. So we are just setting the value to our state.value, which is the previous state here, +1, and then we are returning it. So this will be our new state. Same for decrement, where it is -1. Here, increment by, we are grabbing the state and then our action amount. This amount has a payload. That is the actual argument that we get passed to it. And then for reset, we're changing it back to 0. Okay. After we do the reducers, the last part is the extra reducers. And this is our reset reducer here. So here we create a new store. So this store has a list of slices. So we could have multiple different slices for our store. And that's why our reducers have named this way. Okay, so after the store is created, we can subscribe to it. So this part would kind of be where your UI would come in. So you can subscribe to changes of the state, and then when the state changes, you can also update all of your UI. In this case, we're just changing, we're just debug logging our new state. In order to dispatch our action, so to call our actions, we basically just call store.dispatch, and then we invoke whichever action we want. So right now, this is just calling increment right after our subscription. We're logging out what the new state is. And then in order to unsubscribe from our subscription here, we just call dispose on the subscription. They need to rename that for the subscription that we just created here. Then here again, we are just dispatching the reset. So it'll be resetting it back to 0. And then here we just call our invoke increment by 10, basically. So yeah, simple stuff. Now, what I did here to try to wrap my head around this is I created a card game store. So this would be basically a two-player game, two-player card game, where 2 players have a deck, a hand, and a field that they are playing to. So the initial game state will just be 2 players here. A list of players. Technically, we can have as many players as we want. We have a struct of cards, and the card is just going to have an ID, name, description, power, and defense. And our player is just going to have a list of cards. So you'll have a list of cards for your deck, list of cards for your hand, and a list of cards that you have played out to the field. And basically, when we create a new player, we are just giving it an ID, and then we are creating a new deck. So it's going to be a 20 card deck that we are just adding new cards to. I think in an actual game, you would have the players build their own decks, and then you would have to somehow upload that list of cards to your server or your host or whatever in order to build the the actual game state. But for now, we are just making 20 identical cards with default values here. You could randomize a bunch of stuff here. So ideally, if this was going to be like an online game, you would send, instead of a list of cards, all of this information here, you would just have a list of IDs. So each card in the game would have its own ID to it. So you would have your, whatever 300 card pool, and then your decks would just be like, here is card number 57 and 38 and 209 or whatever. Then you could look up what the ID of your different cards are. So you'd have a list of all your cards, and then you just go through that list for the IDs, and then that's what you would use to show the cards on the table and in your hand and stuff. So yeah, that's the game state, is just 3 decks for each player. I do have a somewhere. So here, our draw card, we have a action that is going to be giving a player ID. So this would be whatever, player 1 is going to draw a card. So here we grab our player list, we find the player whose ID this is. We're going to remove this player from the player list, basically because we're going to add it back later. Here we are just adding the top of our deck into our player hand. We remove that card from the deck, and then we can add the player back to the player list. I'm actually not sure we actually need to remove and add the player, but it made sense at the time. And then we can just return a new state with this player list. And then that's going to be our updated state. We have a play card reducer as well. I haven't gotten that far yet, but this will basically do the same thing. It will take probably a card ID, and then it will take that card from the hand, put it onto the field, and that would be that for the actual game state. Because this is solely concerned about the UI, I wouldn't have like gameplay effects, so like combat and like play effects or whatever. That would happen on the server side. This is strictly what's being shown on the screen. So what cards are in your hand, what cards are on the field. It's basically all the UI cares about. So yeah, we can actually take a look at this in our dev tools. This is in window analysis, Redux dev tools. That's this window here. In order to see your store and the different states, the action states and the difference between them, what you need to do is back in the game store. After you create the store, there is a optional parameter for store enhancer. This was not in the documentation anywhere, at least anywhere that I've seen. Folks on the forums helped me out with this one. But for this, for the enhancer, you'll need to create a default enhancer with the partition state and default enhancer configuration. And then you need to enable the dev tools here. The dev tools will be enabled true, and you'll need to give it a name. With that, you'll be able to see your game state in your dev tools here. So when I hit play, wow, I didn't break anything. Okay. Here we have the initial here. I believe this is our current state. Can I back up? I don't think I can. Nope. I think because it all happened the same frame. So, what I have here is our game state with our player list. We have our player 2 here. This is because we removed player 1 and we added to them. So this will be our 20 decks of cards here for our player 2. They don't have any cards in the hand just yet. No cards on the field. Our player 1 will have 19 cards in their deck. And they have 2 cards now. Not quite sure why they have 2 cards in their hand. Here in our console, you can see that the Redux sample was still running, but you did. So here in our dev tools, you can see the card store that we had. If I did the same with our counter, that would be shown here as well. Here in the action tab, you can see the payload and the type of action that got created. It's weird. So this time we only have 1 card in our hand because I jumped. Anyways, and we actually could do this in the. So here we should see both. There we go. Here's our counter. Initialize. Increment 1, reset, increment 2. All right. So that is Redux. Binding, data binding. Okay, real quickly, in next couple of minutes. Okay. So what I have right here is a health bar. All right, so we have a background, we have a fill mask, we have a fill, and we have a label. Very quickly here, what we can do is before what we would have to do to do anything with our health label and the health bar mask, we would need to grab a reference to whatever our data was going to be. Then we would need to query our root element for the different elements that we needed, our label and our visual element for the health mask. And then we would need to call this basically every frame in order to get our update our values for things. So this will end up changing the health bar mask width by the percentage of our health, which is our current health divided by our max health, lerped for our graphics here. What we can do now is we can bind data to an attribute. So what I have here is I have the width of our health bar fill mask, this red part here, is going to be tied to our edit. So this is going to be tied to an object, which I just have it tied to a scriptable object right now. But this can also be tied to a type. And then we have our path. So our path is just going to be a % health value. This is a length, which is, yeah, that's fine. The binding mode is going to be to target. So this can be one way or two ways. So this could also be a text box that you want to save the text as something else. Maybe it's a chat window that you want to send to your server to send to everyone else. But this is just going to be one way. So to our target, and our target is going to be this width here. Now I made this as a, so yeah, this is just a regular scriptable object. The only real special thing I did was made a length component. That's a UI elements.length. And this is because for width is, if it's a regular float, this is just going to, this width is going to be in pixels. And in order for it to be in percentages, then I want it to be a length. It's a weird thing. But what this means is, close this. I can go into my scriptable object and I can change the health here. And then it will go down and up. There's no cap on it, so it can go way high or negative. I think I can, since the length is just going to grab the percentage of the health, or a health as a percentage, I think I can range 0 to, that should work. Okay, so yeah, additional clamping probably needs to happen since this first bit here does not go all the way. Or you can change your graphics to so the mask is better. So yeah, I guess this goes from 80 something, 8, whatever. We can clamp that and do some lerping. But anyways, that's the basics of how data binding works. It's super powerful. I want to go deeper into binding for to flesh out this card game, so I can bind cards in your hand from the scriptable object. So our deck here can be a list of scriptable objects, but I think I just broke somehow. And then our cards can have images and stuff built into it as well, that so each card can get displayed on the screen without having to actually have game objects as cards floating around. I did the same thing with the health label here. So if you wanted to bind any of these, you just right click, add binding. You can also have your bindings here as well, but I'm doing it per attribute here. So here we are just grabbing the health value and just passing that directly into our text label. You can create custom binding and custom conversions. So we can change we could actually convert the float of the percentage into a color. So as it goes down, we can change the color as well. So we can warp from green to red, make it a green to yellow to orange to red kind of thing going on. Anyways, that'll be something maybe next time. I don't know. Next month, we're going to be at GDC. So this, I don't know if we'll do some streaming from GDC, or we might just skip it and come back April with a GDC roundup or whatever. But anyways, that should be good. And yeah, we will go ahead and end this one here, coming up right at 2 hours. So yeah, we will get this up on YouTube. I know my internet has been flaking out lately, so we have not been streaming, but we will get this up on YouTube as soon as everything comes back online. So yeah, if you guys have any questions or comments, or tell me how wrong I am about web development, please leave a comment down below. And yeah, this is really cool, and I plan to go a little bit deeper into the world of UI and UX development. Yeah, so we will see you guys next time.